Hey everybody, today's lesson is 1.8 absolute value inequalities. So the first three are warm-up problems. These three, you should be somewhat familiar with how to solve an absolute value equation. If you're not, I'm going to breeze through these really quickly. But basically what you do for all these absolute value equations is you write two different equations. One of them you drop the bars and keep the equation as normal. The other one you flip the sign of the 2. So it's not the absolute value part that changes. That part stays the same, but you also equal it to -2. And you solve both answers, and that means that when you plug in that number for x into the absolute value bars, for both answers you get 2. So what I have to do here first is get 3x equals 3. This means x equals 1. That's my first answer. You can check that. When you plug in 1 up here, you get 3 times 1 is 3 minus 1 is 2. Absolute value of 2 is 2. And when I do this one, I get x equals -1/3. Same thing, when I plug in -1/3 all the way up here, I get -1 minus 1 is -2, and the absolute value of -2 is +2. So that's how you're going to attack all of these problems. Same thing here, we're going to equal 1 to +4 and 1 to -4. So 3 over 2x minus 1 equals +4. 3 over 2x minus 1 equals -4. From here, I'm going to cross multiply. I like to put the 4 over 1 and cross. So I get 3 equals, and then when you cross this way, and be careful distributing the 4, you get 8x minus 4. That means 7 equals 8x. X equals 7 over 8. That's our first answer. You can check that and verify it if you want to. And then the next one, same thing. Put the 4 over 1 and cross multiply. Multiply the -4, so -8x plus 4. Be careful with that negative sign being distributed. So I'm going to subtract the 4 from both sides, and I get -1 equals -8x. X equals +1/8. There's our second absolute value review equation. Third one, stop and think. Absolute value is always a positive number, right? No matter what kind of a number that you plugged into an absolute value, your answer is always supposed to be positive. So when can an absolute value ever equal a negative number? Not. Therefore, no solution, impossible, cannot work, no solution. So the thing about this one is you have to be really careful. Anytime you have an absolute value with a negative number, you have to stop and think. You can't just write your two equations like we did the other two and go ahead and solve it. You got to stop and think whenever you see a negative sign with an absolute value equal to it. So just be careful about that one. It's a good review problem to talk about. And now let's talk about how to do these absolute value inequalities. Okay, so we have two different situations here. The absolute value of a being less than 4, and we have the absolute value of a being greater than 4. So I want you to think first of all about this less than 4. Can you give me some numbers that fall into this category for a? What kinds of numbers have an absolute value less than 4? So you should be thinking 3, 2, 1, 0. What other numbers have an absolute value less than 4? -1, -2, -3. Don't those, when you plug in like -3 to the absolute value, it gives you +3, which is still less than 4. So we have some negative numbers that we can take into account here. And so can you think about graphing this? What would our situation look like? Where's like the 3, the -3? Here's 0, here's 3. What kinds of numbers, if I'm shading all the numbers that include an absolute value of less than 4? I'm shading in here, right? All these numbers. And then don't forget about the decimals. Doesn't 3.5 fall into this category, and 3.7 and 3.9? So that's why I'm going to go all the way up to 4 and -4, and I'm going to put parentheses here. So it's kind of similar to some of the stuff we've been talking about in class this week. But this answer is everything in between -4 and a and 4. That means that everything in between -4 and 4 falls into this category. So I just want you to kind of think about what that means, and it's a little bit different doing absolute values with inequalities, but we have the same kind of process over here. Give me some numbers that fall into this category. So numbers that have an absolute value bigger than 4. So that would be like 5, 6, 7, ... Aren't there more numbers? Isn't the absolute value of -5 bigger than 4, and -6 and -7? Doesn't that also work? So again, if I'm going to put these, like this solution on a number line, I know that I have 4 and I have -4, which is what I'm kind of focusing on in my head. And I know that 5 and 6 and 7 work, so I can shade this way, and I can shade all the way up to 4 because all those decimals work. And then the other way, all the decimals that are less than -4, so this way, all of those numbers also work into the absolute value being greater than 4. So I want you to kind of zoom out and think about the difference between these two problems and look at the graphs in particular. These are called less than problems when it's a less than sign, and that means that you're shading in between two numbers. And then a greater problem means you have two different sections. So any problem that has like a greater than sign, you're going to shade left and right forever. So we use like the infinities for the interval notation for these ones. Okay, so that's kind of a graphical representation and a little bit more of a common sense explanation of the difference between a less than problem and a greater problem. So we kind of made up these words, less than, meaning you shade in the middle, and greater, meaning you shade left or right. Okay, so in these boxes here, what I have is just some kind of instructions for these problems. I am going to skip these special cases because I want to talk about these in class tomorrow, but we're going to do problems 1, 2, 3, and 4 down here. And so this first problem is a greater problem because this sign is a greater than sign, which means I am focusing on this section. So I already know what my graph's going to look like. For all the greater questions, my graph looks like this. I'm going to shade left and right forever. I just need to figure out how to do those numbers. So there's like an algebraic kind of process that you can memorize to try and do these greater than and less than problems. So basically it's really similar to the way we did the warm-up problems with the absolute value equalities with the equal signs. We are going to write two different equations, and one of them is exactly the same equation as you see it written. I'm just going to drop the bars. But since this is a greater problem, I'm going to write the word or in the middle. And I'm going to keep the absolute value part the same. And yes, I'm going to use a -4, but I'm also going to flip my sign. Okay, and then these two inequalities, this and this, is all I have to solve, and then I'll graph it and write my answer in interval notation. And this is how you're going to do every single greater than question. Okay, so we're just going to get x by itself here. When I minus the 7 over, I get -3. Don't forget to flip your sign when you divide by a negative sign. I'm going to write flip, and that's just because I divided by a negative. Okay, so I have x is greater or less than 1, or I also have a different answer over here. -3x is less than -11. Don't forget to flip 11 over 3. So what I have to do there is that's two different inequalities, and you guys already know how to graph that and write that in interval notation. So my two numbers, make sure you put them on the number line in the correct order. And I'm shading to the left of 1 because the arrow here is pointing to the left. I'm shading everything less than 1 with a parenthesis on 1. And I am shading everything to the right of 11/3 or greater than 11/3. So parentheses on both. My interval notation is -infinity to 1 and 11/3 to infinity. Okay, so this is a greater problem, which means we have two sections of the number line, two different answers, and we have a union using infinity as our interval notation. Let's talk about this less than question. You should already know what this graph is going to look like. It's going to look like this up here. I'm going to shade in between two numbers, but algebraically, how do I actually get those two numbers? So it's kind of similar to using the +2 and the -2, except what the box tells us up here is to write this as a compound inequality. So I am using -2, and I'm keeping my absolute value in between the -2 and the +2. So this is exactly what it tells you to do up here for the greater than questions. Rewrite as a compound and statement. That's what I did by writing this. So I can actually write it out down here so we have a little bit more room. You just bring the two over with a negative sign and keep your compound inequality. That's what this is called when it's when you have two different inequality signs. That's called a compound inequality. And then once I shade, I'm going to shade in between whatever number this is and whatever number this is after I get the x by itself. And that's how you do all of the less than questions. So all I'm going to do first is minus the 8 from everywhere, because you guys already know how to solve these types of equations, and this gives me negative 10, 2x, negative 6, divide by 2 everywhere, and that gives me my two numbers that I'm going to shade in between once I do my graph. I'm shading in between negative 5 and negative 3. Make sure you put those numbers in the correct order. They are increasing as you get to the right because they're negative. Brackets on both of them because of the equality sign, and I'm shading in the middle, and my interval notation looks like this. Okay, so there's only two choices. It's either greater than or less than, and when it's greater than, you write two separate equations, flipping the sign and making the symbol negative. And then when it's less than, you just bring the number over here, keep everything all lined up and smushed together, if you will, and you're going to shade in the middle. Okay, so two more to practice. Go through this one really quickly. Before you write your two equations for this one, you definitely want to move the 5 over. So we have 2x plus 1 is less than 3. And this is a less than question. So the trick for this one is to bring the negative 3 over here and keep my inequality all squished together into one compound inequality. And now all I have to do is get my x by itself, so subtract 1 from everywhere, and then divide everything by 2. And you're going to shade in between negative 2 and 1, because that means that x is everything in between negative 2 and 1, and I'm going to put parentheses because it's not equal to, and my interval notation is negative 2 to 1. So all the less than questions are set up exactly like this. Then you solve and use what you already know about interval notation and about graphing. Okay, this last one is a greater problem. So for all the greater problems, we write two different equations. 1/4 x minus 3 over 2 is greater than or equal to 2/3. That's equation number 1. You just drop the bars and write exactly what you see. And remember, the second one is almost the exact same. You keep the absolute value part the same, but you flip the sign and make the answer negative. Okay, so for this one, it's got a bunch of fractions in it. I hate fractions. Let's get rid of them. Multiply everything, I believe, by 12, and we can do that in both cases. That will clear all of my denominators. So I'm going to do 3x minus 6 times 3 is 18, and 4 times 2 is 8. And then over here, clear my decimals. I'll kind of do them at the same time here. So 3x minus 18, that part's the same. And over here, I get actually a negative 8. So I just need to solve both of these. I forgot my little word or. This is a greater problem, which means I'm going to shade left and right on my number line. I'm going to start by adding 18 on this side. Gives me 26. 26 over 3 is one of my solutions. And when I add 18 over here, I get 3x is less than or equal to 10. So I have two different numbers, 26/3 and 10/3. 26/3 is greater. I'm also going to shade to the right of the 26/3 because it's telling me to shade all the numbers greater than that. And I'm going to shade to the left of the 10/3. And then I'm going to write my answer in interval notation. So my graph looks like this. Make sure you put them in the right order. 10/3 goes first, 26/3 goes second. And there's brackets on both of them. It's telling me to shade to the right of the 26/3 and to the left of the 10/3. And I have negative infinity to 10/3 with a bracket and another bracket 26/3 to positive infinity. So there's only two different kinds, you guys. There's greater questions, write two equations just like this one. There are less than questions where you just write it as a compound inequality and solve it. The graphs will look different depending on what kind of question it is. And then we are going to save the special cases for class tomorrow. That includes number 5 and number 6, okay? The rest of it you guys should be good on. Thanks for watching. Have a great night.